All right, this is going to be the video for Notes 96, which is on word problems that involve trigonometry. So we have these lovely word problems, and the big thing that you're going to want to be able to do is to draw a picture, okay? So we have an angle of elevation for a 16-foot ladder against a wall is 36 degrees. And then how far is the base of the ladder from the wall? Now, I do not draw pictures well at all in the slightest, so here's my thought. Look, it's a wall. It makes a 90-degree angle with the ground, and against the wall from the ground is the ladder. So the wall and the ground are going to make a 90-degree angle. The ladder is 16 feet long, so there's my 16 feet. And the question is, how far is the base of the ladder from the wall? So that's going to be your X right here. What I'm missing right now is this angle of elevation of 36 degrees. So the idea would be this. Your ladder, I'll try and draw this differently. So your ladder was originally sitting against the floor, right? And somebody said, all right, well, let's go ahead and raise the ladder up the wall. That angle that I'm making right there, that's the 36-degree angle of elevation. So this right here is my 36 degrees, okay? So once I've got the picture drawn, I'm going to do my little reminder here for trigonometry. SOHCAHTOA, right? Remind you about sine, cosine, and tangent. So 36-degree angle right here, this is the adjacent side. This is the hypotenuse, so the equation I'm going to set up for adjacent and hypotenuse is going to use cosine. So the cosine of 36 is equal to the adjacent side over the hypotenuse. I'm going to go ahead and put a little over 1 here so I can cross multiply. So x equals 16 times the cosine of 36. Now this is going to go in a calculator. No expectation that we do this in our head. So let me go ahead and grab a calculator. I do want to make sure that my calculator is in degree mode. So I'm going to hit mode here and make sure that degree is highlighted. On some calculators, it'll actually say, instead of these ads across the top, it'll say the word degree up there. So let's go ahead and do 16. Cosine is right here in the middle. So I'm going to go ahead and grab cosine 36, close the parentheses. All right, so how far is the ladder from the base of the ladder from the wall? I'm going to round off to 2 decimal places, so 12.94. Everything was in terms of feet here. So there is your answer for question number 1. Okay, so that ladder is about almost 13 feet away from the wall. I'm going to go ahead and kill the calculator, right? Get that off the full screen here. And I'm going to go ahead and slide on down to question number 2, okay? Same kind of question, right? So we have a point on the ground that is 126 meters from the base of the CN Tower in Toronto. The angle of elevation at the top of the tower is 77 degrees. To the nearest meter, how tall is the tower? Now, I do want to kind of highlight this to the nearest meter part because that means I am going to round off completely to whole numbers. All right, so here's my tower. I'm going to make an assumption that it is going to make a right angle with the ground. So this point right here, that is 126 meters from the base. So let's go ahead and mark that, 126 meters. So the angle of elevation to the top. So we're going to start at this point, okay? And I am going to basically measure, right, all the way up. We're going to look up to the top of that tower there. This is the 77-degree angle of elevation. And I want to know how tall the tower is. So my X goes right there. Now, as far as labeling goes, we've got the 77-degree angle right here. This 126 is the adjacent side. So it's the side nearest to it. And then this X right here is going to be the opposite side. So which trigonometry equation uses opposite and adjacent? That's going to be tangent. So the tangent of 77 is equal to the opposite side over the adjacent side. Little cross multiplication here to solve, so that's over 1. Let's go, x is equal to 126 times the tangent of 77. I'm not doing that in my head. Let me grab myself a calculator. Actually, can I keep that on top? I cannot. So let's go ahead and slide this over. Oh, too far. Too far. All right, I want to squish the calculator over a little bit, not completely get it off the screen. So 126 times the tangent of 77. Remember, tangent, sine, and cosine are right here in the middle of your calculator. Now, I know I had closed the calculator and reopened it, but the mode should not change just by doing that. You have to do like a factory reset generally to make these calculators reset themselves that hard. So in this case, x is going to equal 546 meters, because it did say to round off to the nearest meter, so that means no decimals. So 546 meters there. Let's go ahead and get rid of that. And I'm going to keep rolling on down to the next problem here. All right, this time we have a plane taking off an angle of elevation of 12 degrees. It's going to reach an altitude of 5,000 feet. I want to know how far it's traveled. All right, so here's the ground. Okay, plane is going to take off. Oops, let's try this again. Okay, and it wants to go at an angle of elevation of 12 degrees. So this angle right here is our 12 degrees. And altitude is this perpendicular distance to the ground. So it's 90 degrees here. So altitude of 5,000 feet. And when I'm asking you how far has it traveled, folks, the plane travels along this hypotenuse edge right here, not the horizontal. So my x is going to be that piece. All right, we've got the picture now labeled. It's drawn and labeled. Let's go ahead and add in those labels for hypotenuse, opposite, or adjacent as needed. So this angle is opposite to the 5,000. So I'm going to label that as opposite. And the x is the hypotenuse. So which of your trig functions use opposite and hypotenuse? That's going to be sine. All right, so we're going to do the sine of 12 degrees is equal to the opposite side, so 5,000, all over x. There's my over 1 there. Let's go ahead and cross multiply. So we're going to have 5,000 is equal to x times the sine of 12. X is not yet by itself, so let's go ahead and divide by the sine of 12 here, divide by the sine of 12 here. And I'm going to put in the calculator whatever 5,000 divided by the sine of 12 is, because that's not going to happen in my head at all, even a little bit. All right, so 5,000 divided by the sine of 12. Let me take a quick look. There are no rounding instructions in this one, so I'm going to go ahead and round to 2 decimal places. So 24,048.67 feet. That is a lot of feet. All right. And you don't have to do any kind of conversion there. It's just that is what it is. Okay. So far 1, 2, and 3, we've seen angles of elevation. I can already look ahead at problem number 4 and see an angle of depression. So number 4 and number 5 are both going to talk about angles of depression. So we want to be very careful when we're drawing these pictures to make sure that they are accurate. All right, so we have an angle of depression from a searchlight to its target on the ground. So I'm not going to worry about the angles yet. Okay, so here's my searchlight. That is 26 feet above the ground. Okay, and somewhere down here, there's a point here that is the target. Okay, so beam of light's coming down here. We're going to make the searchlight be perpendicular to the ground. And I am asking how long is the beam of light. So there we go. The problem is we need the angle in the picture, right? So angle of depression here from a searchlight. So in the angle of elevation problems, when I drew it, right, I drew across and I basically was measuring up, all right? And that creates this angle. So now let's take a look. If you were sitting at the top of the searchlight and just looking out, okay, and then what's going to happen is you're going to be looking out, and I want you to basically depress or lower your eyes until you see, oh, look, here's my target on the ground. So the angle here is outside of the triangle. It's this angle, I'm going to label it right here. This is my angle of depression here. That is 58 degrees. Now, this is great. This is fine. It looks great. The problem is I need an angle inside this triangle to actually use sine, cosine, or tangent. So I either need to figure out this angle here or this angle here. Now, one of the easy things is these two angles, the 58-degree angle right here and this angle right next to it, are what are called complementary angles. They form a 90-degree angle. So using that information to my advantage, if I take 90 degrees minus 58, I should get, I'm going to double check this in a second, but I believe it's 32 degrees. Okay, now I am going to pop the calculator up and just leave it off to the side here. I want to double check that math before I go too far and all of a sudden I get it wrong. What on earth did I just hit? Let's try that again. 90 minus 58. Yes, it is 32 degrees. So now using the 32-degree angle, 26 feet here and x here, I'm going to set up a problem. So 26 is the adjacent side, x is the hypotenuse, and that's going to then tell me, oh, I need to use cosine. So the cosine of 32 is equal to the adjacent side over the hypotenuse. Once we've figured out the 32 here, I no longer need to worry about the 58. That's not going to become part of my problem. So let's go ahead and put a 1 here, a little cross multiplication. So 26 is equal to x times the cosine of 32. Let's go ahead and divide both sides by cosine of 32. Whoops. I said it right, wrote it wrong. All right, cosine of 32 here. So in the calculator, we're going to take 26 divided by the cosine of 32. All right, no rounding instructions were given. So that's going to be 30.66. I believe everything was in feet, so it is in feet. And there is my answer for number 4. Get rid of the calculator there. All right, so make sure you're drawing the picture correctly. Once you've got the picture correct, you can set up the equation and solve from there. All right, last problem on the page here is problem number 5. We have a lighthouse 159 feet above sea level. All right, so there's my lighthouse, 159 feet above sea level. Angle of depression to a ship at sea. So somewhere over here, right? We're going to make sure the lighthouse is perpendicular to the ground. So somewhere over here, I have a ship. I don't draw ships very well, but hey, look, it's a ship. The angle of depression is 19 degrees. Find the distance from the ship to the base of the lighthouse. The base means the bottom of the lighthouse here. So let's see. If I connect the dots from the top of the lighthouse to the ship, let's talk about angle of depression. All right. So angle of depression, I want you to imagine you're standing at the top of the lighthouse and you're looking straight out. All right, just look around. Hey, look, there's clouds, there's birds. Awesome. Now, you're standing at the top of the lighthouse, you're looking straight out, and now you notice if you lower your eyes, right? Your eyes are up here, normal. You're going to lower your eyes. Hey, look, there's a ship down there. All right, so you were up here, you lower your eyes, lower your eyes, lower your eyes. Okay, there's the ship. So again, this angle outside the triangle, that is the 19-degree angle of depression. Okay, so same thing we did in the last problem. This angle of depression plus this acute angle inside the triangle are complementary. They add up to 90 degrees. So if I take 90 minus 19, let's see, 90 minus 18 should be 71 degrees. Okay, now I can use this triangle because I know this acute angle. I can talk about these two sides now in terms of labels. So across from the 71-degree angle, this is going to be x. This is your opposite side. Right next to the 71-degree angle, but not the hypotenuse, that's your adjacent side. So what uses opposite and adjacent? That is going to be the tangent. So we're going to do the tangent of 71 is equal to the opposite side over the adjacent side. All right, go ahead and put this over 1 if you need the reminder. Little cross multiplication here. X is equal to 159 times the tangent of 71. All right, and no expectation that this is going to happen in your head. So immediately let me grab my calculator here. All right, so 159 times the tangent of 71. All right, so how far is that boat from the base of the lighthouse? 461.77 feet. Rounded off as appropriate. Okay. All right. Go ahead and close that out. Yep. All right. So there's all little bits, parts, and pieces for number 5. This is where I'm going to go ahead and close the video because this is everything from that note sheet. As always, please let me know if you have any questions or concerns, and I'll see you in the next one.